The electric field intensity. Electric field intensity, which is E. Electric field intensity is defined as the force acting per unit positive charge in a given circuit, or is defined as a force acting per unit positive charge in a given electric circuit. Force acting per unit positive charge in a given electric circuit, whereby we have the E is equals to F over what? The Q. We call this equation 1. Remember our F from the Coulomb's law. We have the F is equals to, we have the K, Q1 and Q2 over what? R squared. We call it equation 2. Substitute equation 2 in equation 1. We have what now? E is equals to, we have, instead of writing K, F, you write the K, Q1, Q2 over R squared times, this one will serve as 1 over F, or 1 over Q, sorry. Because this it can be equals to write as E is equals to F times 1 over Q. It's the same thing. Thereby you have the Q cancel 1 of the Q. E is equals to the K, Q, right, over R squared. Equation 3. What is our K? The K is equals to 1 over 4 pi E epsilon, where we have E is equals to equation what? 4. Substitute 4 in 3. We have E is equals to what now? 1 over 4 pi E epsilon times 1 over times Q R squared. E is equals to Q over 4 pi E epsilon R squared, equation 5. And this is the formula for electric field intensity, or electric field intensity. This is the formula for E is equals to Q bracket 4 pi E epsilon, as the case may be. And in a nutshell, electric field intensity from the formula. What is the SI unit of electric field intensity? Remember, E is equals to F over what? The Q. What is unit of F? Newton. What is unit of charges? Coulomb, which is the same thing as Newton per Coulomb, as the case may be. That leads us to the potential, electric field potential. Electric field potential is refers to as, okay, let me just clean it. Electric field potential. When we talk about electric field potential is electric field potential, from the name, electric potential is defined as the work done in moving a unit positive charge from one point to another, which is V. Electric field potential is defined as the work done in moving a unit positive charge, or in moving a unit isolated positive charge from one point to another, where we have the V is equals to work done over Q. We call it equation 1. Or in a nutshell, we have the V is equals to the KQ over what? R squared. The KQ over R. That's the electric field potential. That's the formula. We have what? V is equals to the KQ over R. Where in some cases you have V is equals to KQ bracket 1 over RA minus 1 over RB respectively. And the unit is always B in joules per coulomb, because V is equals to work done over Q. And work done is in joules, and this one is in coulomb. So we have joules per coulomb, or joules per coulomb, as the case may be. That specifically lead us to some topics. We have the capacitor. What is capacitor? From the name capacitor. Capacitor. When we say capacitor C, and it's usually measured in what? Farads. The capacitor V. The capacitor is defined as their opposition to the flow of current in a given circuit. Let's assume this is our circuit. So the opposition to the flow of electric current, this is the current I. The opposition to the flow of electric current in a given circuit is called capacitor. Capacitor is defined as opposition to the flow of electric current in a given circuit. That is what we refer as what? Capacitor. Then it's usually measured in farads. We have the microfarad, we have the nanofarad, we have the picofarad, and so on and so forth. Let's now proceed to capacitance. Capacitance of a capacitor. Capacitance of a capacitor C, respectively. The formula is C is equals to K over V. The capacitance of a capacitor is defined as the quantity of the unit positive charge that is acting. That's the ratio of the charge, electric charge, in a given circuit over potential difference. The ratio of electric charges Q in a given circuit over potential difference, respectively. When we have the C is equals to Q over V, we call it equation 2. C is the capacity of the capacitor, Q is the charges, and V is the potential difference, mathematically. And this is the potential difference, respectively. And we can make use of the formula, we can make C of the formula, we can make V of the formula. If you want to make use of the formula, divide by 1. Q times 1, we have the Q is equals to CV. We make it to be subject of formula, the Q is equals to CV. Then we have, if you want to make V of the formula, we have the C is equals to Q over V. Cross multiply, this times this, we have the CV is equals to Q. I want to make this of the formula, divide by C, divide by C. C cancels C. V is equals to Q over C, as the case may be. Let's start talk about the factors that affect capacitor. There are factors that affect capacitor. Number 1, we have the area between the plate. Number 2, the distance between the plate. Number 3, dielectric medium. These are the factors that affect the capacitor of capacitor. The area between the plate, the distance between the plate, and the electric medium, as the case may be. Now, capacitor of capacitor is usually arranged in series as well as in parallel. Let's see arrangement of capacitor in series. Arrangement of capacitor in series is when you have, this is a symbol of capacitor. Here is the C1, here is the C2, and here is the C3 respectively. This is the capacitor in series. And this is the flow of electric currents that flow in them. And here is going to be the potential difference between them respectively. So, in a nutshell, the capacitor that is arranged in series, we have different potential difference. We have different potential difference, this is V3, but they have the same current. Capacitor in series will have the same current flowing through the capacitor, but different potential differences. And the formula for capacitor is 1 over C equivalent is equals to 1 over C1 plus 1 over C2 plus 1 over C3, as the case may be. Let's assume this is 3, this is 3, and this one is what? 2. So as the case may be, we have 1 over C1 is equals to, C1 is 1 over 3 plus 1 over 3 plus 1 over 2. You can take the LCM. 1 over C equivalent is equals to, the LCM will be what? 3 times 2. So here will be, which is same thing as 6. This one will be 3 goes in this 2 times 1 is 2 plus 3 goes in this 2 times 1 is 2 plus 2 goes in this 3 times 1 is goes 3. Then C is equals to 1 over C equivalent is equals to, this plus this is going to be, this plus this 4 plus this 7. It should be 7 over 6. You find the E. C equivalent is equals to, this times this, C cross multiply, this times this, we have this 1 times 6 is equals to, this times this is what? C equivalent times 7. Want to make C equivalent of the formula, divide by 7, divide by 7. 7 cancels 7. C equivalent is equals to 1 times 6 all over 7. C equivalent is equals to 6 over 7. And anything you have in the farads. Let's now see capacitor in the parallel. Capacitor in parallel, the formula for capacitor in parallel is, this is the capacitor arranged in parallel. This is a capacitor that is arranged in parallel. Capacitor arranged in parallel will have different currents flowing through them. C1, C2, and C3. We have different current flowing to them, but the same potential difference. Unlike the series, this is a parallel. Unlike the series, that we have the same current flowing through them, different potential difference. But here, the capacitor in parallel, you have the same voltage, potential difference flowing through them, but different current flowing through them respectively. And the formula for capacitor in parallel is C equivalent is equals to C1 plus what? C2 plus what? C3, as the case may be. Let's assume we have, here is 2 farad, here is 2 farad, and here is the what? 3 farad. Just say C equivalent is equals to, what is this? 2 plus 2 plus 3, which is same thing as 7 farad, as the case may be. Let's now see what is the formula for capacitor in series. The formula for capacitor in series is the formula for the energy stored in capacitor. The formula for energy stored in where? In capacitor. The formula for energy stored in capacitor is E is equals to 1 over C V square. That's the formula. The formula of energy stored in capacitor is 1 over 2 CV square. That's the formula of energy stored in a given capacitor. And this is where we are going to stop for capacitor. Thank you.